In this problem, it is given that f of x is the solution of differential equation dy by dx plus 2xy plus 2x equal to 0, and similarly g of x is the solution of the second differential equation which is given, and also given that f of x and g of x have same constant values. That means the constant values of this solutions are equal. If they are equal, we have to check which of the options holds good. Now the given differential equation is dy by dx plus 2xy plus 2x is equals to 0. This can be written as dy by dx plus 2x into y is equals to minus 2x. So we can say that it is clearly in the form of first order linear differential equation, whereas p of x is 2x and q of x as minus 2x. Now the integrating factor is nothing but e power integral p of x dx, which is nothing but e power x square. Now the general solution. General solution of this differential equation is y into integrating factor, which is e power x square, is equals to integral of q of x, which is minus 2x, into integrating factor, which is e power x square, plus let us say some constant c1. Now this can be written as y into e power x square is equals to, we know the differentiation of x square is 2x, so it is in the form of f dash x into f of x, which is nothing but f of x. F of x is e power x square with negative sign plus c1. Now this can be written as y is equals to minus 1 plus c1 by e power x square. And it is given that the solution of this differential equation is f of x. So we'll replace this y by f of x. So f of x is nothing but minus 1 plus c1 by e power x square. So c1 by e power x square can be written as f of x plus 1. Let it be some equation 1. Similarly, if I find the solution for the next differential equation, which is dy by dx plus 2xy is equals to 2x, the difference between the first and this will be only minus. So even in this constant term also, there will be only a difference of minus. So f of x, instead of plus 1, it will become minus 1. So this is g of x, sorry. Let it be some equation 2. So from equation 1 and 2, we can write that f of x plus 1 is equals to g of x minus 1. So g of x is nothing but f of x plus 2, which is nothing but option A.
The value of the integral is integral of dz by z plus 1 z plus 3 equals to minus pi y, where c is the closed contour such that the integral value equals to minus pi I. Means we have to choose the contour c in order to get the answer minus pi I. So we know that 1 by 2 pi I f of z dz equals to sum of residues of f of z at pole locations. So if we do that thing, we will calculate the contour is nothing but mod z plus 3 is 1, which is option C is correct.
Find the area of xy dx, where r is nothing but the region bounded by the coordinate axis and the line x plus y is equal to 1. Now the coordinate axis, this is y is equal to 0 and this is x is equals to 0, and the line x plus y is equals to 1. Now we have to find this region. Now clearly x is varying from 0 to 1 and also y is varying from 0 to 1. Now the given integral is nothing but double integral over r xy dx dy. If I consider x as 0, it is varying from 0 to 1. Now if I consider y as 0, it will vary from 0 to 1 minus x, which is xy dy dx, which can be written as x is equals to 0 to 1, y is equals to 0 to 1 minus x, xy dx dy. If I integrate, it will be x is equal to 0 to 1. If I integrate y, it is y square by 2 between the integrals and x. So this is nothing but integral x is equals to 0 to 1 x by 2. I'll take this half out of the integral, half into x into 1 minus x whole square dx, which can be written as half into x is equals to 0 to 1 x minus 2x square plus x cube. If I expand this and simplify, Then the integration is nothing but half into x square by 2 minus 2x cube by 3 plus x power 4 by 4 between the limits 0 and 1. If I substitute the limits, value will be 1 by 24, which is option B.
Open loop transfer function of unity feedback system is given by k divided by s into s square plus 8s plus t. Using Routh's criteria, determine the value of k for the stable system. In order to determine the range of k for the stable system, first of all we have to form the characteristic equation, that is 1 plus g of s. H of s is the characteristic equation. Here h of s is nothing but a unity feedback system, hence it is 1. 1 plus g of s is equals to 0. So s cube 8s square plus ts plus k equals to 0. So if we form the RH table, 1 t 0 8 k 0, this is 8t minus k divided by 8 0 0, this is k. K should be, means all the first column elements must be positive. That means all the entries must be greater than or equals to 0. So for the stable system, third row elements 8t minus k by 8 greater than or equals to 0, that is k should be less than or equals to 8t. This is the one condition for the stability of the system. As well as fourth row element, that is k must be greater than 0. So k is greater than 8t. This is the condition. Hence option D is correct.
Given C of t, that is system response, t minus 1.25 e power minus 2t plus 2 into e power 4t, which is subjected to ramp input. Now what is steady state error? Steady state error is defined as limit t tends to infinity r of t minus t of c of t. If you see here, we have e power 4t function. Okay, at t tends to infinity, what happens? The output response c of t, it will reach to infinity, because e power 4t is nothing but an exponentially increasing characteristics we have. Okay, directly we can put it as steady state error as infinity, or this is limit t tends to infinity. Since we have ramp response, this is t minus 1.25 e power minus 2t plus 2 into e power 4t. Okay, at t tends to infinity, if you substitute it, this is infinite. Okay, answer is D.
Question is, in the circuit shown, V0 will be 0 at frequency. Okay, to frequency. So V0 equals to V0 plus minus V0 minus. If V0 plus means V by R plus R by 2 into R by 2. If we get V by 3, this equation. So V0 minus, we will get this V into SCR plus 1 whole square plus SCR. So if we equate this equation with this equation, that is 1 with 2, then we will get omega as 1 by RC, which is equals to 1 by 2 pi RC. That is option C is correct.